Welcome back everyone. In this video we are going to create a Flappy Bird clone. So really this is an opportunity to learn how you can create games on Android. And Flappy Bird is a relatively simple game to create. If you haven't heard of it, it was released in 2013 to the frustration of many iOS users because it was fiendishly difficult. At the same time, being very simple. It was very popular, and actually there is an interesting story behind it about the developer actually removing it from App Store because of all the criticism that he got because people found it so difficult to play. But anyway, you can go away and Google it that if you want to find out more. I just want to show you very briefly how the game works. So here's floppybird.io. You can go and have a look at it now, and this just shows you an online version of the game, which is pretty similar to the one that we are going to create. So click. Oh, I didn't even get a pass the first 5. You keep pressing or clicking on the screen to keep Floppy moving up and down, and then the idea is that you have got the randomly positioned pipes. Hey, I got past 4 tubes, which then you have to get through, and absolutely if you hit the pipes you die and game is over. So it is very simple, but it will allow you to see all of the basic of Android game creation. How we can do collision detection, have sprite animation, round the screen zone, and scoring of course up there. So it should be a lot of fun. Alright, so that's it for this video. I hope you enjoyed this video. Don't forget to like and subscribe my channel if you're not yet. Let me know if you have any question, and I'll see you guys in the next video. Welcome back everybody. In this video we are going to create a Flappy Bird clone part 2. We are going to start by downloading Introducing-GDX, which is open source gaming library, which I'll truly recommend it if you are going to be hand coding games. It is actually course platform as well, so you can build not only Android apps but apps which work on Windows, Mac, Linux, iOS as well. So it is really good system to learn, but we are still just using Java and we are very much creating a native Android game here. It just gives us a lot of features that we will otherwise need to code ourselves on the Android system. So if you haven't already, go to libgdx.com and then click get started, and then set up a project, then next step, and then click download button, and then download the gdx setup.jar file. You can save anywhere you want. It is just a small little Java application. Fortunately, you already got Java installed because we have got Android Studio up and running. So you should just able to tap the gdx setup.jar file, and then you will get this. So this allows you to set up your app. So let's call it Flappy Bird, and then package, remember, it's something like com dot and then your name or your company name and then the app name. So Flappy Bird, and game class can be whatever you like. It is just name of the class. I'll call it Flappy Bird, and then you just choose where you want to it to appear, and then to get the Android SDK path, we can actually get that from Android Studio. So load it up and click top right side 3 dot and SDK manager, and then right there at the top it is your Android SDK location. So that will be very similar to this. If you are on Mac, it will obviously be something different if you are on Windows or Linux operating system. So just copy that and then paste it back in. And we only want to develop for Android here. So to simplify things, I'm going to get rid of the other three. There's a lot of support online for other platforms if you want to start developing for those as well. But we'll stick with Android for now, and all the other options I just keep to default and click generate. Now you'll likely get this message. You have a more recent version of Android build tools than the recommended version. I'll definitely go for yes there, and similarly yes for the using the more recent Android API version. That will just mean that it is easier to run in Android Studio without doing any tricky alternation on the app. So this will then generate the app for you, and there we go. That's done. Build was successful. That's sounding promising. So now we just go back to Android Studio and open that in the user way. So over to my location, data, Android, Flappy Bird, and then let's open it, Flappy Bird. Okay, well that be fine. And this video we are just going to go as far as having a quick look at what is actually included and what we get. We run the default project and then we'll actually start building Flappy Bird in the next video. So here you go. Let's have a look and see what file we have got. So straight away you might notice some difference here. There is no REST folder that we are used. We do pretty much everything in Java, and here is our Flappy Bird class, which look like little bit scary compared to everything that we are going to use. We have still got our create method, which as you can imagine runs when the app is run, and now we have a render method as well, which is what is will mostly be coding in the render method essentially gets run again and again and again. So you can think of it as an ongoing loop, and that's where we'll put our code to animate our sprites, to do our collision detection and everything like that, to see where the game actually works. So here I have already run my emulator and run this app by clicking play icon. So we have got a few new classes there as well. We have got a sprite batch. You can maybe imagine that that's essentially a batch of sprite that's then processed to the screen. And we have got a texture, which are basically images that we work with and think of them as sprites as well. So like the Flappy Bird will be our first texture or sprite that we are going to work with. So all this does is creates a new sprite batch called a batch, and then it creates a new texture on image, which is from the batlogic JPEG file. Then it creates a background color which is red, and then it draw the image at position 0, 0, and then in the process of drawing the batches. So let's look. So the output is simply that first up notice by default that we are looked into landscape mode, and we have got this red background and the BatLogic logo there as well. So that's it. We have now set up GDX and we have got the code that we need to get our app working, and we are going to start in the next video by changing background and displaying and animating our little Flappy Bird sprite. Alright, so that's it for this video. I hope you enjoyed this video. Don't forget to like and subscribe my channel if you're not yet. Let me know if you have any question, and I'll see you guys in the next video. Welcome back everybody. In this video we are going to working with a sprite in our game Flappy Bird : So in this video we are going to see how we can add our own sprite to our Flappy Bird game, and we'll do little bit of basic animation as well to make our board flop up and down. Alright, so to be able to add our sprite, we are going to need some images for them. So you can download those from link in the description below. Zip file that download, and then just unzip that zip file, and you will have a little folder with a very simple. We have got a background, we have got a board in 2 states, so you might just be able to see there got wings up and then wings down, and then we have got 2 tubes. So this is a tube coming from bottom and coming down from the top. That's all we need. And of course we are going to need to add those to our app. The way I'll do it is to go over Android Studio and open the Android and asset folder. So you can see that where we have got a bad logic JPEG file, the default, and then I'm just rebel that in the Finder. You can open it in the Windows Explorer instead, and then just select those images and drag them into the asset folder, or just copy those files and simply paste into the asset folder. Like that. Here we go. Now you can see that already here, and I'm actually going to get delete of bad logic JPEG because we don't need that anymore, and then read more MD as well. Alright, just before we add our first sprite, there's one change we want to make, and that is we noticed that last time the app is landscape mode by default. Now that's great for most games, but Flappy Bird is actually one of the few games that you can play in portrait mode, or that's how we are going to make it anyway. So if you go into Android manifest and then Android manifest.xml, you can see we have got a usual stuff that we are used to, and then a bit of other stuff as well. The key things that we want to change here is the screen orientation. So Android screen orientation landscape to Android screen orientation portrait. Okay, so now we are in a position to add our code. So pretty much everything we do is going to be in this single Flappy Bird class, and I'm just going to get delete of everything that here and here as well, and we are starting from scratch. So as I mentioned in the previous video, we have got 2 main method here. The create method, which happens obviously when the app is run, and the render method that happens continuously as the app is processed. So our main here is to add a couple of sprites. We are going to start with the background, and then we are going to bring in our Flappy Bird, and we add our sprite as a badge. So sprite badge is exactly what you might think. A sprite is essentially an image or a character or a background, something like that, and we create a sprite badge to manage displaying and animation of those sprites. So the first thing that we are going to do to add our background is to begin our badge. So this just tells the render method that we are going to start displaying sprite now, and we are only going to display the one, but we are going to display the background. So instead of having texture called image, let's have a texture called background. And our texture is just an image. It is exactly the same things, but in games creation they are known as texture rather than images. And then we are going to define which image this background is going to be. So we want background equal new texture double quote, and of course we are going to use background PNG. So now this background refers to this texture, and then to display it we take our badge and then we draw, and you can see we have got a bunch of options there of way that we can draw things. And then main ones that we're going to be using is like this first one. So we give the texture first, then the x coordinate and y coordinate, then the width. And that one, if you could see, it will say height. We give the x coordinate, y coordinate, the width, and then the height. So start with the texture background, then the x coordinate. I want this background to be a full screen, so I want it to begin at the bottom left, so 0 0. Then I want the width to be same as the width of screen, and I can get that from the GDX library using gdx.graphics.getWidth. Here we go. Next, we want the height of these things to be the same as the height of the screen, which is gdx.graphics.getHeight. And then that's all we are having this time. So then we use batch.int. So we have now created our render method, and we have told it to repeatedly display the background on our phone screen. And we are stitching it so that it is going to be whole screen, because the bottom left of our image is going to be at the bottom left of the screen. The width is going to be the width of the screen, and the height is going to be the height of the screen. So let's just take a look. There we go. There's our lovely background stitch of full screen. Now let's bring our board in. So as you can imagine, we create a new texture, which I call a texture Flappy Bird up, and then we'll set board to be equal to a new texture Flappy Bird up.png. Okay, so probably a lot of started with something like bash drawer and then Flappy Bird up, which is a good start. And then you are thinking, why? What do we want to the x coordinate to be? Well, if we want the board to be in the center of the screen, we want the x coordinate to be the center of the screen. Now we know that the screen width is that gdx.graphics.getWidth. So if we divide that by 2, that will give us the center of the screen. So let's try that out. So the gdx.graphic.getWidth divide by 2, and then similar with the height, gdx.graphics.getHeight divide by 2. And then you may have noticed that if we don't need to specify the width and height, then of the actual asset of texture, we don't need to. So why not just let the size be whatever the size of the sprite is, because I didn't specify that I wanted it a certain size. So that will be a very reasonable solution. So if you run app, that you will have seen board in your app screen. Wonderful. And then you might have thought, wait a minute, that does not look quite center, and that's because it is not quite central, and that because what you give when you give this coordinate is you give this coordinate of bottom left of this sprite. So that's this bit here, because it is a square, so it is around there, and that point there is exactly the center of the screen. But of course what we exactly want is the center of this sprite to be in the center of the screen. What we are going to need to do is move this sprite half it is width to the left, and then half it is width to the down, and then center of the sprite will be in the center of the screen, which is what we want. So we need to get the width of the sprite or the width of the Flappy Bird up, which we can do using Flappy Bird up.getWidth. So exactly the same as graphic.getWidth, but obviously on Flappy Bird up this time. And we want to subtract Flappy Bird up.getWidth half the width of the Flappy Bird up, so that the center of the Flappy Bird up will be in the center of the screen. And exactly the same for the height, subtract Flappy Bird up.getHeight, but we want subtract half of this height of the Flappy Bird up this time, not half of the width. So well done if you figure out that. There is going to be a lot of math in our Flappy Bird. Game development is quite math heavy, and you are going to need to do quite a lot of thinking and working out formulas to get everything to appear in the right place. And there you go. That board now looks much more central than it did before. So we have got our board, we got our background. Our only other aim for this video is get the board floppy. So remember, this looks static, but this render method is exactly begin run again and again and again. So all we need to do is to, instead of drawing board each time, we need to draw floppy board up, and then we need to drop floppy board down the next time, and then floppy board up, and then floppy board down, etc. We need to go back and forth between floppy board up and floppy board down. So what I'm going to do is I'm going to create an array of texture, and I'm going to call it boards, and then we are going to have a boards. This time, instead of begin new texture, it is going to be a new array of texture which we create using texture and then square bracket, and we need to specify the number of items in our array. So boards equal new texture array. We have two boards, and there's going to be two. It is going to be floppy board up and floppy board down. Then we just specify each of them. So boards 0 is going to be boards 0 equal new texture floppy board up dot png. So same as what we have before. And then boards 1 is going to be boards 1 equal new texture floppy board down dot png. So now, instead of displaying just board every time, we are going to be displaying boards 0 and then boards 1 and then boards 0, etc. Now of course, to manage that, we are going to have to keep track of which one we want to display at any given time. So I'm going to sprite those up a little bit, that there's all the board information is kept together. And the way I'm going to deal with that is have an integer, which is I'm going to call floppy state. That's initialized going to be 0, int floppy state equals 0. So floppy state just flips between 0 and 1, and that will keep track so which one we want to display at each time. So now we are just going to do a quick check. So say if floppy state equal 0, then we want to set floppy state equal 1. Else floppy state equal 0, so floppy state will just oscillator go back and forth between 1 and 0. And then instead of floppy board up, we are going to use boards floppy state. I'm going to replace that each time it pops up. There you go. So now we should find that instead of just having a static board, we got a board which oscillate between boards 0 and then boards 1, which are our two texture with the wings up and then wings down. So we should get this animated board. Alright, so we have got our background and we have got our flopping board. In the next video, we'll see how to make the board respond to tap and flop up and down in the way that we saw in the previous video. I hope you enjoyed this video. Don't forget to like and subscribe my channel. If you're not yet, let me know if you have any question, and I'll see you everybody in the next video. Welcome back everybody. In this video, we are going to interacting with sprite in our Flappy Bird column. Now that we have got our Flappy Bird and our background, we want to start to get the board interacting with us. So Flappy Bird has got a very simple control mechanism. Essentially, all you need to do is tap the screen and then the Flappy Bird will start flying around. So how do we get a tap to be detected? It is very straightforward. We do it in render method and we look for if GDX dot input, and then you can see there are a lot of possible options there. So you can even work with the accelerometer and other fancy bits. We want to look for just touch. So this will be called every time the screen is tapped. So for now, let's just log something saying that it has been tapped. When you are working with the GDX app, it is best to use the app login. So we use GDX app log and then something like touch. I'll give it for don't touch me. So now we should find, of course, that we get a something as that the log every time we touch. So now we should find, of course, that we get a something as to the log every time we touch the screen. And what we actually want is for this board to drop out of the sky. And then for when we tap the screen, for the board to essentially be given a show as if something hit it from underneath and it flies up and then continues, it falls. So essentially we want to create a gravity system which is actually surprisingly easy to create. So let's get the log showing and then I'll tap the screen. And there you go. You can see there it is definitely responding to that touch. Alright, so if we want to move the board talking, let's set up gravity and then we'll set up our touch to interact with that. So for our gravity, we are going to need to know two things about this board. We are going to need to know it is position and it is velocity or it is speed. So let's set that up. So we'll create those as floors board y equal to 0, and then I'm going to call the position board y. Now the x coordinate of the board is always going to be the same. That's the horizontal coordinate. It is always going to be in the same center of the screen. It appears to be moving to the right, but it actually stays in the center of the screen all the time. So it is only the y or vertical position that will change, and I'll set that to 0 initially, but we don't want it to be 0 for long because we want it to be equal to where the board starts. So that's going to be initially this position here. Now we could build this into the render method, but we only need to get the height once right at the beginning. So to make it more efficient, we'll do it in the create method, so it only happens once. So we want board y to be set board y equals gdx.graphics.getHeight divide by 2, subtract boards, I'll give 0, and get heights divide by 2, and then boards floppy state get height divide by 2, and both those boards have the same height. The only difference between them is one, they have got a wings up and then another got a wings down. So actually it doesn't matter which one we use. So just to make things a little clear, I'm going to use board 0 rather than board floppy state. Alright. So now this will work as it stands in the same way as it has already. So let's set up our velocity, which is going to be how fast the board is moving. I'll make it for a float and velocity equal 0, and again I'll set that initially to be 0, and then what we'll do is we'll increase the velocity each time. So velocity, the render loop is called, and then we'll increase or decrease the board y position of the board by the velocity. Board y minus equal to velocity. So this is going to increase the velocity each time. The render loop is called, and it is going to decrease by the board y coordinate by the velocity. So we are going to get this effect of gravity that as it falls, it is going to fall faster and faster. Now one thing I'm going to do before we run that is, if this is how you run it, then board will likely drop off the bottom of the screen before you can do anything about it. So I'm going to create a variable that we'll need anyway. It is an integer called int GameState equals 0, and this will just keep track of the state of the game. So initially we are going to obviously just have the board hovering in the middle as it is just there until the user tap the screen, and then gravity will kick in. So far all of this we need to check if game state is not 0. So we are going to do all of the processing only if game state is not 0. And then when game is tossed, the screen is tossed, we are going to set game state equal 1. Now I'm actually going to just copy that, and we are going to have this in an else statement there, because we only need to do this particular check if the game state is 0. And most of the time, especially when there is lot going on, the game state is not going to be 0. So to save having to do the check every time, we'll put it inside else statement here. And of course, when you are making a game, you need to be fairly careful about system resources and do things as efficiently as possible. So we'll take reasonable step to make our game efficient even though our game is not particular resource heavy. Alright, so that will make game state equal to 1, which will then kick in with our velocity and our board movement. So it is only this velocity which is changing everything, then it will do the recalculate location depending on the velocity, etc. And we want the floppy state calculation to happen either way as well. So there will be a lot more code in this game state. It's not 0 part because this is going to be where we put our game logic and our tubes and everything else, but for now it is pretty brief. So let's run the app. There you go. Now that was fine, but a little bit slower than I would have liked. So you can of course experiment with how you want this to work, but what I'm going to do is set another variable here called gravity. And because one seems to be a little bit slow, I'm going to initialize set it to be equal to 0, and let's make it a float because we are going to be using it to work with the floats. And you might well want to have a 1.5, 2.5 or any decimal point if you want to get it just right. So instead of increasing velocity by 1, we'll increase it by velocity equal velocity plus gravity. Alright, so we'll see how that works. Now the way we want our interaction to work is if the game state is not 0. So if we are playing the game, we want when the user tap the screen for the board to receive essentially a sweep upward, which is the same thing as given the board a certain velocity. Now I have played around with this, and I think a velocity minus 30 works quite well. Let's run it and take a look. So if we give the board a velocity of minus 30, because we are subtracting the velocity each time, that will subtract a negative number, so it will add to the board's height and board will shoot up. Now slightly alternation as well. I think it makes just a little bit more sense, even thought it will work in much the same way to adjust velocity. So let's give it a try now. So tap once, there you go. And you can see you can now tap and the board does not indicate head upward and then falls back down. So actually looking at that, and one more alternation before we are done with our game control is I found during development it is frustrating that the board disappear off the bottom of the screen, and so it is difficult to test things. So what I'm going to do to avoid that is look at board Y, and if board Y is greater than 0, so this will stop the board going off the bottom of the screen, it will stop also. However, our ability to shoot the bird up. So let's have a quick. Our velocity is less than 0, and then that will allow us to shoot the bird up either when we are in playing mode. So we are in above the bottom of the screen, or if we give it a tap, so essentially it will allow us to move the bird upward. Whenever we like, it will stop the bird moving downward once it gets to the bottom of the screen, which just make our lives a lot easier. When we are doing testing, we don't have to get in there and keep the bird at the top of the screen all the time. So here you go. Alright, I'm liking the way that move around now, and then let's see what happens. So the bottom of the screen, then the bird stop, and we can still move the bird upwards. So believe me, that will make our life a lot easier when we are testing. Alright, so now we have created our interaction with our bird. Our next step is bring in our tubes and start creating several of them and get them moving from right to left, and we'll do that in the next video. I hope you enjoyed this video. Don't forget to like and subscribe my channel if you're not yet. Let me know if you have any question, and I'll see you in the next video. Welcome back everybody. In this video, we are going to bringing in the tubes in our Flappy Bird column. So now we have got our background and our bird moves just how we want them to go up and down like that. Wonderful. The next thing to add is the tubes. So I'm going to start by creating texture for them. So we are going to have a texture called top tube and call texture bottom tube. We'll do two stuff together in create method here. So top tube is going to be a new texture from top tube PNG, and bottom tube is also going to be a next texture, of course this time bottom tube PNG. Alright, so now let's add them in, and we'll add them here after the game state is not 0, the game state is active. So we'll need to start a batch begin, then I'll just add the batch in command there as well. And then as before we need batch draw and texture, I'll start with the top tube. Now let's think about where we want to put this. So we want the X coordinate first. So the top tube, we want the bottom left to be around here. So if there's the center of the screen, we want to shift is up by half of the whatever the gap is going to be. So we have got the gap between the two tubes there. So if this is the center of the screen, we want it shift up by half of the gap and left by half of the width of the tube, so that we'll keep it center. So if we get the center of the screen, which we get from gdx.graphics.getWidth, so that's the width of the screen, and we divide that by 2 to get the center of the screen, and then we want to subtract the width of the tube, so that top tube.getWidth divided by 2. So that's the X coordinate. The Y coordinator is fairly similar. We are going to get gdx.graphics.getHeight, and we want to divide that by 2, and we want to add half of the gap. Now the gap is something that we might want to alert or make the game easier or harder. So I'm going to create that as float, and I will start off with it 500 and see how that works out. So we want half of the gap. Alright, And we don't need to specify the width and height because we can just use the default width and height of sprite themselves. And then very similar for the bottom tube. Let's draw bottom tube. So the x coordinate is going to be exactly the same. So gdx.graphics.getWidth divided by 2, and we'll use bottom tube.getHeight divided by 2. Even though they both have the same width, it doesn't really matter. The y coordinate is going to be a bit different, because for top tube we want the bottom left to be around here. For the bottom tube, the bottom left is exactly going to be way off the bottom of the screen. So we are going to want to get to the center them, subtract half the gap to move half the gap down, and then subtract the height of the tube to take us to the bottom left of the tube, which is going to be way down here somewhere. So we get that using gdx.graphics.getHeight and divide by 2, gap divide by 2, again the height of the tube, so subtract bottom tube.getHeight. And just before we run that, we are going to have one issue here, and that is the background is drawn after the tube, and because the background is full screen, that's going to be on top of the tubes. So we don't actually see the tubes at all. So that's not good. So what I'm going to do is actually begin the batch, cut and paste right at the beginning here. And then we'll draw the background first, and then we just use the same batch here to draw the tubes. So delete batch.begin and batch int as well. So then we are drawing background first, and then the tube, and then the board. The board is never going to be on top of the tubes anyway, so that doesn't really matter. But even if it was, we did properly want the board to be in front of the tubes. So quick summary there. The order that you draw those is in the order that they will be displayed or layered onto the screen. So run and let's have a look. And there you go. There's our flopping board and tubes. Wonderful. And I'll keep that distance as 500 for the moment. When we play the game, we might adjust it, but that looks good to me. Now next thing we are going to need is to randomize the position of the tubes. We don't want them to be central every time. We want them to shift up and down. The tricky question is how much do we want to move them up and down, where you want to use the full height of the screen. But we obviously don't want them off the top of the screen. So what I'm going to do is consider this to be half of the gap, and then say another 100 for that bit there, because we don't want that bit to be off the screen. So then the maximum amount that we want to be move them up from the center point is going to be half of the height of the screen, which will take them right to the top minus half of the gap, and then that 100 for this top bit here. So that was half of the height of the screen minus half of the gap minus 100. So let's set up that. So that's going to be float maximum offset. So the amount is moved up and down, and we'll set here, and we'll set up here as well. So maximum offset, as I said, it was going to be half of the height of the screen. So gdx.graphics.getHeight divide by 2, subtract gap divide by 2, and another subtract 100. And then we are going to need a random number generator to generate our random gap. So let's set up that. I'll call it random. Bring that in. So down here, what I'm actually going to do, temporarily I create a new random number every time the screen is tapped, and then we'll see that it is random moving up and down, but then we'll move that code to somewhere better later on, because we don't want to move the tubes every time the screen is tapped in the final game. So let's have a float tube offset. and we are going to set that here after the velocity tube offset, and we want to random generator. We have actually set up our random generator, so let's do that. Here it is just going to be a random generator, and then we have to create a float from that random generator. And remember, tube offset random generator dot next float, create a random number between 0 and 1. So first off, we want to not have a number between 0 and 1, but we want to have a number between a half and minus a half, because we are working from the center of the screen here. So I'm going to take my random number generator and subtract 0.5 from it. I need to specify that 0.5 is float so that the type are not problem. So now we have got a random number between 0.5 and minus 0.5. We want to multiply that by kind of scale factor as it will. So remember, we want our maximum value to be half of the top of the screen minus half of the gap minus 100. Now we have already got a half here because the maximum of this is 1/2. So if we get the top of the screen, that's gdx.graphics.getHeight, and then subtract the gap. So this will mean that if this has a maximum value of 1/2, then the maximum value of the whole things is going to be half of the height minus the gap, which is almost what we want, but we want it to be half of the height minus the gap minus 100. So we are going to need to minus an extra 200 there, because remember we are multiplying by a half here. So this will give us a minimum possible value of this time, a half minus this, a half minus that time a half, and a minimum value of the negative of all of that. So in short, we are going to go from the center of the screen and we are going to move up to around there. So the top of the screen minus the gap and minus 100 pixel. Alright, so that's our tubes offset. So all we need to do is add that to each of the y coordinate here, so that we'll shift it up or down depending on where the random number here is more or less than a half. So now every time we tap, that should give us a new tubes offset. So we should see those tubes moving up and down with each tap. Let's run and take a look. Here we go. First tap, excellent, and then wonderful. They are shifting up and down perfectly, and they are not going to high and they are not going to low. Alright, the last thing that we are going to create those tubes to do is move right to left. So let's set up that. I'm going to create a float tube velocity equal 4, and I'll try this out. The tube velocity of 4 should work out. And then we are going to need to keep track of the tube x coordinate, because that's going to change as it is moving left. So I'll call that float tube x, and then initially we want to set tube x to be our this code here, which was our initial x coordinate. So that's tube x now, and same with this. And then let's see what happened is each time we decrease tube x by 4. And actually what I'm going to do is again raise tube x each time we tap just so that we can bring the tube back into the middle and a good look at when we want to. Let's run and have a look. Here you go. We tap and there it is, moving out when I think is a perfect good speed to the left. So now we have got our tube more or less behaving as we like. That what you are probably thinking is how are we going to create more than one tube? I'm going to have 4 sets of tubes, so top and bottom, and I'm going to move them from the right to the left, and then when they are off the screen to the left, I'm going to change their X position so that they jump back to the right of the screen, and that will look like an unlimited infinite set of tubes coming from the right to the left, but actually there's only 4 of them and I have chosen 4. Just because if you are playing this one, a big screen, then you might be able to see lots of tubes at once. On this screen, we probably get away with or maybe even 2, but I'm going to go with 4 just to be safe. And I'm also going to put them half a screen width apart, and if I do that, then we should not have any problem missing tubes or not enough tubes to display to the user. Alright, so let's have a couple more variables. So I'll have a number of tubes as a variable, and that's going to be 4. And actually use my tube velocity here rather than number. Let's fix that using by tube velocity. So a number of tubes is 4 float distance between tubes. So here we can set up the distance between tubes as I said half of the width of the screen. So distance between tubes equal gdx.graphics.getWidth and divide by 2. Alright, now let's create these tubes. So some of these we are going to need to change them slightly. So we are not going to have just one tube X. Now we are going to have a 4. So I'm going to make this an array of float, and this is going to be a float array tube X equal new float array, and then the tube size, or in fact we could use size number of tubes, and it doesn't like that because I need number of tubes to be an integer. Alright, similarly the offset are going to be different for each pair of tubes, so let's make those an array as well. Alright, so then down here we are going to set up our tubes. So I'm going to do this is a for loop. So we have an I wish start at 0 and less than the number of tubes, and each time is increment. So for each pair of tubes, initially we want to set their x coordinate and their offset. For I equals 0, I less than number of tubes, and I each time increment. So let's now bring our code out of the just touch method and into the create method. So instead of tube offset, now we are using tube offset I, and similarly tube X I, and so that first one the offset, that's absolutely fine as it is because we want to each one to be random, but this one we don't want each to have same x coordinate. We want for now the first one to have that x coordinate because we want it to appear in the middle of the screen. So we can see it's slightly away, but for each one we are going to want to multiply I by the distance between the two. So the first one is going to be in the center, the second one is going to be half a screen away because distance between the tubes in half a screen. The third one's going to be a whole screen away, and then fourth is going to be 1 and a half screen away. Alright, so that should now create necessary tubes. So let's now display all of those tubes. So I'm going to copy this for loop because I want exactly the same for loop here. There you go, and instead of tube X we want tube Xi, and again tube Xi. and then we are still using top tube and bottom tube. They don't change from one to other, but tube X does. So we are now working with tube XI, and we also want tube offset I rather than just tube offset. Alright, so with that should now display 4 tubes all with random offset. So up and down from the center, and they should move steadily from their entire position. So the left, now run and have a look. There you go. Wonderful. The one issue that you may have noticed, of course, is that the tubes are disappearing. They are moving to the left, and then they are not doing anything else. So as I said, we need to do a check to make sure that when they get off the edge of the screen, then they shift back over to the right of the screen. So we'll do this check here. So if it is less than, we need to be a little bit careful. We cannot use 0 because then it will magically move over even when it appears on the screen there. So we actually want to use minus, and then the width of the top tube or bottom tube, it doesn't really matter which we use. So that will make sure that it is off the edge of the screen, because it will have gone to the coordinate down here somewhere, which is 1 tube's width to the left of the screen. So it is definitely will be fully off the screen by this point. So if that's the case, we want to shift it to the next right, and to do that we are going to take tube XI and add to it. We're going to want to 4-half screen width, because that's the total distance between our tubes. But in the general case, that's going to be number of tubes multiplied by distance between tubes, and add to it number of tubes multiplied by distance tubes. So that should shift it over to the right, the correct amount. So that is can then came back in again, and then if it is not off the edge of the screen, then we moved it to the left as we initially planned. Alright, well, that's compiling. I think that's perhaps the tubes we are slightly too close together. So let's just try changing that to instead of half the screen width, we'll change it to the 3/4 of the distance of the screen width. So just to see, it doesn't really matter, but I think that's make the game a little bit more playable. So run and have a look. Alright, so now we have got 1, 2, 3, 4. We are going to get another tubes there. So those tubes are now coming thick and fast all the way. So now we have got our tubes. We have got them hopefully a reasonable distance apart. The main thing absolutely that the game is not correctly doing is any kind of collision detection. So we absolutely want the bot to, if it hits the tubes, for the game to be over, and that's what we are going to be in the next video. Alright, I hope you enjoyed this video. Don't forget to like and subscribe my channel if you're not yet. Let me know if you have any question, and I'll see you in the next video. Welcome back everybody. In this video we're going to work with collision detection in our Flappy Bird colon. So it's looking pretty good so far. So we have got our bird who moves in the way that we want them, and we have got our tubes which repeat forever, and tubes are randomly given height, so that's they makes it quite difficult to get the bird through them. So our next challenge is to work out how to do collision detection. So we want to take our bird and make it so that when he or she bumped into a tube, that the game is over. let's do that. But first, there is just one small change that I have noticed, and that is we want the tube offset to be raised whenever the tube move to the right of the screen. So when we do that jump, we want the tubes to be in the different place. And at the moment, you can see we have just got the same 4 locations repeating again and again, which is what we don't want. So we just add the tubes offset, create over to the here. Just copy and paste to this code. Alright, so how do we do collision detection? Well, essentially what we need to do is create shapes for our board and our rectangle so that we know where they are in shape. And then we look using GDX for collision between those shapes. So let's start off by creating a shape for the board, and a pretty good close to the shape of the board is circle. So I'm going to create a circle for the shape of the board, which is just going to overlap on the top of the board essentially. So let's create that up here, and this is going to be a circle. I'll call it circle board circle. And this is going to be a new circle, and then we just want to create a circle that overlap where the body is. So it is going to be quite similar to this, but instead of using batch, we are going to use shape render. In fact, we create our shape render up here. So shape render, which is new shape render. So you should think of this just like batch. It enables us to draw shapes, but batch is just draw texture, and we cannot do collision detection directly on texture. We need to do collision detection on shapes. So let's do that down here. So shape render that begin just as before, and this time we are going to specify a type of shape, and all our shapes are going to be filled in. So we use shape render dot shape type dot filled. You can see there's a few other options there that you can imagine you might want to different situation. Then for now we are going to have a color as well. Shape render dot set color. So I'll choose for blue so that we can see that our shapes are all in the right place. And then we are going to take our board circle and set it up to match the actual board itself. So we use board circle.set, and we are going to set the center of the circle gdx.graphics.getWidth divide by 2. So that's going to be just center of the screen. And the x coordinate, the y coordinate is going to be board y, but remember board y is the y coordinate of the bottom of the screen. So we need to add half of the height of the board to get the center of the circle. So we want board y plus board's floppy state dot get height divide by 2, and then the radius of the circle we also want to be board's floppy state dot get width. So this will give us the center of the circle. The x coordinate of the center of where the board is, the y coordinate of the center of where the board is, and then the radius of the board to the distance from the center of the board to the edge of the board, which will just close as half of the width. And I can now take my shape render and render a circle, and I'm going to get the x, y and radius from my board circle. So it is shape render dot circle board circle dot x board circle dot y and board circle dot radius, and lastly shape render dot int. So now we should find we have a blue circle on top of our board all the time. Obviously we are not going to have that there permanently, but it will just show us that our board circle is in the right place. I'm actually just going to move that up to the top, and just before we run that, there is one or two actually small changes we need to make. So we need to create our shape render and our circle down here in the create method. Board circle equal new circle, and shape render equal new shape render. Alright. So now we should find that we have got bird blue circle on top of our bird, and that blue moves exactly with our bird, and we can use that blue circle for collision detection. Obviously, we are going to remove the actual appearance of the circle when we are done testing. So run the app. There you go. There's our circle. Wonderful. So for now, we are going to create 4 rectangles at the top and 4 at the bottom for collision detection check purpose. So I'm going to create an array of rectangles. So an array of rectangles called rectangle array top tube rectangles, and another array of rectangles called rectangle bottom tube rectangles, and then I'll define them down here. So top tube rectangles is going to be a new rectangle array, and there is going to be 4 of them in it, but I really want to use number of tubes, and exactly the same for bottom rectangles. Bottom tube rectangles, new rectangle, number of tubes there. And then for each of those, we are going to define the rectangle or new rectangle. So we'll just take top tube rectangles I, new rectangles. And the same for bottom tube rectangles I, new rectangle. Is a new rectangle, and that everything is correctly initialized in the create method, and then we'll actually add the location of the rectangles down here. So we do that here, and it is going to be very similar to drawing the tubes. So it is going to be creating a rectangle for each one which overlaps the tube graphic itself. So let's create top tube rectangle I, and that's going to be a new rectangle tube xi, and we create rectangles and we use an x and y coordinate of the bottom left and then the width and the height. So the x and y coordinate of the bottom left are going to be exactly the same as the y and x coordinate of the bottom left of the tube. So that's here. Just copy and paste it, and then the width of the rectangle is going to be the same as the width of the tube. So that's just top tube dot get width, and the height is going to be same as height of the tube, that is top tube dot get height. And then bottom tube rectangles I is also going to be tube xi, and then the y coordinate is going to be the same as the y coordinate of the bottom tube. So that's here, copy and paste as well. And then width and height as before is just going to be bottom tube dot get width and bottom tube dot get height. So those rectangles should overlap exactly the existing tubes. So now it is just matter of displaying them. So remember, we are only displaying them so that we can be sure temporarily that they are in the right place. We don't need to display them in the real game. So we'll exactly delete this code later on, but it will be useful for us now. I'm actually going to copy for loop again, that is here. So each time we loop through, we want to take our shape render and render a rectangle, and we have got x, y, width and the height again. So we get those straight from here, just copy and paste it because it is exactly the same, and in fact we want to copy and paste these two because we want to be sure that the blue rectangle that we are displaying. So let's have a look. We should now have a blue rectangle on top of all of the tubes as they move from right to left. Alright, this is looking good. We have got blue rectangle, and there you go. Wonderful. Now we are playing a game with no sprite, just rectangle and circle. And that we have got our rectangle and circle. So let's do this in this loop here because we need a loop anyway. We need to check whether the circle is cooled in with any of the tubes. So we'll check is if, and then there is a method GDX class called intersector which obviously we use to interact things, and we want dot overlaps, and then you can see we can overlap circle and rectangle. So we want to overlap both circle and top tube rectangles. We want to test whether they are overlapped, and we want to do the same with the bottom rectangles as well. And for now, we'll just log gdx.f.log collision. Yeah. So we should now be able to detect whether the bot has collided with any of the rectangles, and if it has, we'll get a log. So let's take a look. So here you go. Start play, and you can see there, and you can see the collision appearing log there. Wonderful. So now we have got our collision detection. So now we no longer need our shape render. So I'm actually going to comment it out, all our shapes render code. And just run and test your game. So now we are playing along with Sprite. Let's just make sure that we are still getting the collision detection. There you go. Lots of collision when you bumped on the tubes, then you'll get the collision log. Wonderful. So one small change before we finish this video, I'm going to delete off the fact that initial tube, you remember, starts off in the middle. We don't want that to be the case. We want it to start off on the right of the screen. So I'm going to add that gdx.graphics.getWidth, and that will mean that the first tube starts off on the right of the screen as you want, and then it will just come into the screen. Alright, so we have got our collision detection. We are pretty much done. All we need now is a kind of game management system. So we want to display the score, and we want to start and stop the game when the user dies. So we'll deal with the first of those to the score in the next video. I hope you enjoyed this video. Don't forget to like and subscribe my channel. If you're not yet, let me know if you have any question, and I'll see you in the next video. Welcome back everybody. In this video, we are going to work with game scoring in our Flappy Bird colon. So we are pretty close to done with our Flappy Bird game. The two main things that we are missing, kind of scoring and the facility to end the game when the user dies, then start again and again. So we are going to work our scoring in this video, and then we'll do the kind of game management part in the next video. So scoring is reasonably straightforward. It's have a general scoring system, so that when the bot goes through the gap, obviously without actually colliding with the tubes, they get an extra point. Now what I'm going to do is actually look at the x coordinate of these tubes, and I'm going to see what the x coordinate of the tube is, and then when the tube gets to there, if the user has not died yet, then they will get an extra point. So the way I'm going to deal with that is by having a score variable, and this will be an integer which is initially 0, and then we are checking the x coordinate of the tubes. I'm going to check to see if any of them have the left coordinate at the center of the screen. Now I'm not going to check for exactly equal to the center of the screen, because remember, we are moving those 4 pixels at the time, so it might not get there. So I have to check to see if it is less than the center of the screen. So let's see how we are going to do that. So reasonably straightforward. We can look at if tube xi to get the x coordinate of the left hand side of the particular tube. And then we want to check whether that's less than the center of the screen. So that is less than gdx.graphics.getWidth. So simply we could say score plus plus. Now of course that is itself is not going to work very well, because the score is going to get very high very quickly, because every time it runs, if the tube is on the left hand side of the screen, it is going to add to the score. So as always, there is a number of ways around this, but what I'm going to do is keep track of which tube is our active score. So next one that we are expecting to come in the instantly. So let's have an integer. I'll call it scoring tube, and initially first scoring tube is going to be the 0 tube. So instead of checking all the tube, we only check for the next one, the scoring 1, and now we don't need to put in the loop either. So we'll add 1 to the score if that happens, and then we also add to scoring tube if it is less than 4. And scoring tube plus plus. Divide by 2, else scoring tube goes back to 0. So we'll just looping round and round. We'll start with the scoring tube of 0. So we'll check for that 1, and then that 1 will get there first, and then as soon as it does, we'll start looking for the scoring tube of 1. So that will mean that the score is only increment by 1 each time, and actually instead of 4, let's change that to number of tube. So let's just log the score each time, gdx.app.log score, and we'll need to convert that to a string, that is string.value of score. And a couple of quick fix in this code. We want to scoring tube to be less than the number of tubes minus 1, because scoring tube is going to 0, 1, 2, 3, 0, 1, 2, 3, etc. We don't want to be able to get to 4, because we don't have a 4th tube as it were. We have 0, 1, 2 and 3 tube. Alright, now we should find that the score is logged each time we get a pass on of the tubes. Great, so that's looking good. So in this video, I'm also going to show you how we can display the score in the screen. And then we'll finally look at the game over screen in the next video. So that is pretty straightforward. We'll do it down with the rest of our rendering, and we want the score to be in front of everything else. So I'm going to create here. Now write the code with the GDX. We need to create our font. Now I'm going to just use the default font, but we do need to set that up, so we'll do that here, bitmap font, and I'll call it font, and along with everything else we'll set it up, create method here, font new bitmap font, and then I'm going to set 2 characterize of this font. I'm going to set the color, and it is just going to be the white, and then I'm going to set the size of scale, and we do that actually font.getData.scale, and I found a scale of 12 to work pretty well. Alright, then we just go down to our bash drawing, and I'm going to draw it, so it is going to be at the bottom left of the screen. So we take our font and we draw, and you can see that we start off by starting the bash and then the string that we want to draw and then the X and Y position. So the badge of course is just the same badge that we are using for everything else. Font, draw, badge, and then we want to take the string dot value of score as the actual text that's going to go on the screen. And then I'm going to go for 100, 100. So that should give us something at the bottom left of the screen. Alright, so we have created the bitmap font up here. We specify the size and color, and then we have actually drawn it down in the render method. So let's take a look. You can see our score number is there, but it is lower than we expect. And I think what is actually going on there is that the Y coordinate that we give here is actually the top left of the screen. So I'm going to increase that to 200 to give that a better look rather than having it on the bottom of the screen. So run it again. So there you go. So I like that position. We can now play the game and enjoy it. Well, it lasts because now we can play as long as we like, and whatever happens, we don't die. So that's what we are going to change it in the next video. We are going to enable collision detection to actually detect a collision. In that, it will end the game when the board hits one of the tubes, and obviously give the user the opportunity to play again and again. Alright, so that's it for this video. I hope you enjoyed this video. Don't forget to like and subscribe my channel. If you're not yet, let me know if you have any question, and I'll see you guys in the next video. Welcome back everybody. In this video, we are going to work with game over screen in our Flappy Bird colon. Alright, we are nearly there now. We have got a scoring system and we have got our tubes displaying as we want them, going on forever and ever. And we have also got the board moving and the collision detection working as well. So all we need is for the game to actually respond when the user hits the tubes or indent the bottom of the screen there, and for the game to be over, and for the user to be able to tap the screen and start again. So first up, we have already downloaded game over graphics, that is here, Android asset folder and game over PNG. Obviously, when you are creating your own game, you need to create your own graphics, but this will work as for now. Now we are going to add this to our game, so let's create a new texture for game over. Create up here, texture game over, and then we'll set it up here, game over, new texture, and then game over dot png. Alright, so let's just remind ourselves how we want this to work. We want when we get a collision detect, we want the game to stop and for the game over png texture to be displayed on the screen. We also want option for the user to the tap on the screen and start game again. So let's make that happen. So the way I'm going to make that happen is bringing in a new game state. So for we have got two game state, 0 which is the very beginning and 1 which is playing the game. So we are now going to have a game state of 2 which is here. So that means that the game is over and we want to do that here as well. So I'm going to remove the ability to move the board after it is got to the bottom, and we are just going to have an else statement here to say that if the board is not above the bottom of the screen. then game state is 2. So what do we want to happen when game state is 2? Well, we want all of this to stop happening. This is now only going to happen when game state is equal to 1. So we are going to have all of that first and we'll add this else if game state equal 0. And our final option is else if game state equal 2. And now that only thing we actually want is our game over message. So let's draw that. So batch, draw, and we want our game over and we want it in the center of the screen. So x is going to be gdx.graphics.getWidth divided by 2 minus gameover.getWidth. And then the same for the y coordinate, gdx.graphics.getHeight divided by 2 minus gameover.getHeight. So we'll just run our game and check. We should now have a proper game over system that will do everything we expect. Restart the game, so when the game stops, the tubes will stop moving, the score will stop increasing, but the board will keep flopping, which is fine. And then we are just going to need to add that facility to tap to restart game again. Here we go. Wonderful. Notice that we cannot interact with the screen at all the movement when we die. Now all we need to do is to copy this code and paste it down here, and now we are going to have some interaction. So what do we want to happen? We definitely want the game state to be equal to 1 to start playing the game again. So we want to set board Y back again. For that we want to set up the tube again. So this code is we need to happen twice. So let's put it in a separate method. I'll call it start game and I'll call it here, and also add start game into here after the game over as well. And I think there is a couple of other things that we need to change here. We need to set the score back to 0. We also need to set the scoring tube back to 0 and velocity back to 0. So that we are checking for the first one again. So now we should find that we get the game over screen, and then when we tap the game over screen, we are back to the beginning of the game again. And everything has been reset. Let's run and have a look. Here we go. So I'll die and then restart again. Okay. Wonderful. So I have get 2 points and then goes back to 0 again when we restart. Wonderful. So there are definitely a few improvements that can be made. I believe that you can make the best Flappy Bird game that you could imagine. I hope you enjoyed that process, and I hope you are now having some ideas about a game that you could make using those ideas. One of the great things about making game for phone is that they don't need to be big and compiled. Just small little apps like Flappy Bird can be hugely popular. So I hope you have some great ideas and use these skills that you have learned in the few lectures. So put them into practice. Best of luck and happy coding.